Welcome to Right to Know training, presented by SUNY Schenectady County Community College. This video outlines the safety protocols and legal protections in place for all employees working with hazardous materials. In this training, we'll cover the key elements of the Right to Know law and how it protects you in the workplace. You'll learn how to identify hazardous substances, locate and read safety data sheets, and understand labeling systems and GHS pictograms. We'll also discuss your rights and responsibilities when working with chemicals, and walk through the proper procedures to follow in case of an emergency or exposure. The Right to Know law ensures every employee has access to critical information about hazardous substances they may encounter on the job. This law ensures public employees are trained annually, have access to chemical safety data, and know how to respond to emergencies. Understanding these procedures helps protect the health of your coworkers, students, and yourself, and ensures that SUNY Schenectady maintains compliance with state and federal regulations. Familiarize yourself with the lab layout and where to find emergency safety equipment. Seconds matter in an emergency. SDS sheets provide essential information. Make sure you know how to access and interpret each section.
Many of the chemicals we use in the lab are potentially dangerous, especially under high heat, pressure, or when they're mixed with other chemicals. There are two main tools that we use to identify chemical hazards: safety data sheets and chemical labels. Every chemical in the lab is required to have a technical document called a safety data sheet, or SDS, usually provided by the manufacturer. These were formerly known as material safety data sheets, or MSDS. The safety data sheet is a one-stop shop to find out about a chemical's properties, hazards, and safety precautions. Know the location of the safety data sheets in your lab and review them before working with a chemical for the first time. GHS is an acronym for the Globally Harmonized System of Classification and Labeling of Chemicals. This new system provides an international standard format for safety data sheets. All SDS must now be organized into 16 sections. Section 1, Identification. Here you'll find the chemical's name, description, and the manufacturer's contact information. 2, Hazard Identification. This section lists signal words, warnings, and safety symbols. 3, Composition, a list of ingredients. 4, First aid measures. What's the required treatment for a person who's been exposed? 5, Firefighting measures. 6, Accidental release measures. These are instructions for containment and cleanup of spills or leaks. 7, Handling and storage requirements. 8, Exposure controls and personal protection. This describes OSHA's exposure limits and recommendations for PPE. 9, Physical and chemical properties, such as appearance, odor, pH, flash point, solubility, and evaporation rate. 10, Stability and reactivity, how to avoid hazardous reactions. 11, Toxicological information. Find out about the likely routes of exposure symptoms as well as short and long-term effects. Sections 12 through 16 aren't mandatory, but you should at least be familiar with them. Ecological, disposal, transport, and regulatory considerations. Section 16 is for any other pertinent information. This is where you'll find the date that the SDS was prepared along with the last known revision. Safety data sheets provide a lot of information about how to use chemicals safely in the lab. But there's also another way to learn about a chemical, and that's by reading its label. The new GHS format requires each chemical in the lab to be labeled with the product name, a signal word such as danger or caution, physical, health and environmental hazard statements, precautionary statements, pictograms, first aid instructions, and the supplier's contact information. Pictograms consist of a symbol on a white background, framed in a red border. Each pictogram represents a specific hazard. Health, flammability, toxicity, compressed gases, skin and eye protection, unstable explosives, oxidizers. An oxidizer is a chemical that initiates combustion through the release of oxygen. Environmental hazards and acute toxicity. Now you know how to identify potential chemical hazards by looking at both safety data sheets and chemical labels. In our next lesson, we'll examine some important techniques for handling chemicals safely.
Let's review the GHS pictograms from the previous video. Flammable, toxic, corrosion, irritant, oxidizer, gas under pressure, health hazard. Even if you're sure, it's always a good idea to review the basics. Chemical labels are designed to share important safety information at a glance, giving you the key details you need to handle each substance safely and confidently. A well-labeled container helps prevent accidents, ensures proper storage, and keeps everyone in the lab informed of potential hazards. When transferring a chemical into a secondary container, it's important to label it right away. The label should include the same key information as the original container so that anyone using it knows exactly what it is and how to handle it safely. Instructors face several exposure risks in the lab each day. Chemicals can cause burns, irritation, or release harmful fumes. Biological materials may carry contamination risks if not handled properly. Physical hazards include cuts from glassware, burns from hot surfaces, and UV exposure from sterilizing equipment. Before beginning any lab work, take a moment to review the hazard assessment and ask yourself, what type of materials am I working with? Are there any physical, chemical, or biological risks present? Whether you are an instructor or a lab employee, identifying hazards before you begin and following the PPE guidelines is essential to maintaining a safe working environment. A binder containing every SDS is located in every laboratory. It is the instructor's responsibility to make themselves and the students aware of potential risks before or at the beginning of every laboratory session. In chemistry and biology laboratories, there is inherent risk. However, with proper education, use of PPE, proper handling, storage and disposal procedures, there is no need for panic. In the event of a spill or emergency, notify your supervisor, lab tech or chemical hygiene officer, in addition to campus security at extension 1308.
It's inevitable. Accidents will happen in the laboratory. Accidents, by definition, are unforeseen, but your knowledge of lab safety will help minimize the likelihood of accidents. And in this lesson, we'll talk about safety equipment found in the lab. These items may help you save a life if and when an accident occurs. When working in a lab for the first time, look around and identify the location of the safety equipment. Every lab must contain a safety shower and eye wash station. Both should be tested weekly to ensure they're working properly and the water is clean. If a chemical or flame exposure has occurred, yell for help and immediately move to the nearest safety shower. Remove the saturated clothing and thoroughly drench the affected skin under the shower. If your clothes or skin are exposed to flame, then drench your entire body and have someone call 911. The eye wash station is used for rinsing your eyes if they're exposed to hazardous chemicals. Hold your eyes open and thoroughly rinse for at least 10 minutes. The next piece of safety equipment is the fire extinguisher. There are 4 types of fires: Class A fires consist of ordinary combustibles, like wood, cloth, and paper. These fires can be extinguished by water or general-purpose extinguishers. Class B fires include organic solvents and flammable liquids, and Class C fires involve electrical equipment. Class B and C fires must be smothered with chemical foam extinguishers. Putting water on these fires will only make matters worse. Water will actually cause the fire to spread, and you can even electrocute yourself. Class D fires involve combustible metals, which aren't very common in the lab. That's why most labs contain dry chemical fire extinguishers, which are installed close to the exits. Dry chemical extinguishers are effective against Class A, B, and C fires. If a fire occurs and it's too large for you to extinguish, evacuate all personnel immediately and call 911. Don't attempt to use a fire extinguisher unless you have been trained to do so by certified trainers, such as the local fire department. A fire blanket can be used to extinguish small flames on workbenches and floors. It can also be used to help someone whose clothing is on fire. Never wrap someone while they're standing. This can force the flames upward toward the head and neck area. Instead, help the person to the floor, wrap them in the blanket, and help them roll until the fire is out. Each lab should have a first aid kit that contains bandages and antiseptic for minor injuries. Evacuation routes should be posted near the exits. It's important that you know multiple evacuation routes in case one is blocked. Another helpful piece of safety equipment is the chemical fume hood. It's a ventilated, enclosed work area that protects you from toxic vapors. Turn on the exhaust fan. Make sure the hood is venting properly. The opening is covered by a window called a sash, which can be raised and lowered. For most applications, the sash should be open to either 8 or 16 inches. Never store chemicals under the hood, and always clean and remove materials when you're finished working. Test your safety equipment regularly to make sure each item is ready in case there's an emergency. In our next lesson, we'll examine how your behavior in the lab can help keep you and your coworkers safe.
You have the right to a safe workplace and the responsibility to follow protocols, ask questions, and report concerns. Wear your PPE before entering the lab. No food, no drinks, and always tie back long hair. These aren't just rules, they're how we protect you. Let's watch this review video to go over some of the basics.
The lab environment is hazardous by nature. The actual risk is largely determined by you and those working with you. It's your responsibility to know and follow the rules and be able to recognize potential safety hazards. The first consideration is proper dress. What you wear in the lab can help prevent serious, even fatal injuries. Often, you'll be working with chemicals that could harm you if they come into contact with your skin. So the best way to prevent skin exposure is to wear clothes that cover your entire body. Shorts and sandals leave your skin exposed, so instead, wear long pants and closed-toed shoes. Remove jewelry before entering the lab and tie back long hair. Bring only the things that you need into the lab. Leave all personal items like backpacks, purses, or jackets outside so they don't become contaminated. Now that you're properly dressed for the lab, let's take a look at personal protective equipment, or PPE. For general lab work, a lab coat, safety glasses or goggles, and gloves are required. Always button your coat and try to keep the cuffs tucked into your gloves. Wear a chemical apron if you're working with splash hazards, volatile, or reactive solutions. Safety glasses can protect your eyes from flying debris. However, these glasses won't protect you from splash hazards. That's why you may need to wear chemical-resistant safety goggles. Always wear gloves in the lab. Be sure to choose the most appropriate type. You need gloves that are resistant to the chemicals you'll be handling. These gloves are non-absorbent. Even so, Chemicals can leach through over time, so it's a good idea to change your gloves and wash your hands frequently, especially if they've come into contact with chemicals. Thermal and puncture-resistant gloves are used for handling extremely hot or cold materials, such as when using the autoclave, handling dry ice, or handling sharps. Some chemicals produce dangerous vapors. A respirator can protect you. However, by law, you must first complete the proper training. So ask your lab manager or instructor about respirator training. Always remove PPE and wash your hands before leaving the lab and entering public areas. And be aware that you can spread chemical or biological contamination by touching items such as light switches, doorknobs, or even phones while your gloves are still on. Dressing for the lab and wearing personal protective equipment will minimize the risk for exposure or harm, but clothing and PPE aren't enough to keep you safe. We'll take a closer look at safety equipment in our next lesson. Respect the lab and respect your colleagues. Your behavior goes a long way to ensuring that the lab is a safe environment for everyone. The first consideration is to follow the written standard operating procedures step by step. Never eat, drink, chew gum, or apply makeup while in the lab. You don't want to contaminate your skin or risk ingesting poisonous chemicals. You could also contaminate your experiment and ruin the results. Never work alone. Always have at least one other person in the lab so that you can help each other in case of an emergency. Good housekeeping will prevent accidents too. A cluttered lab is a dangerous lab. Dispose of any trash or debris on the floor which could cause someone to fall. Never place any chemical bottles on the floor, not even temporarily. If you do make a spill, check the safety data sheet for the appropriate response. For a routine spill, clean it immediately and place a wet floor sign. Keep your workbench clean and organized. Have only the materials you need. Store away all unneeded items. Don't place materials near the edge of the workbench where they can easily be knocked off. Never try to pick up broken glass with your bare hands. A cut or puncture caused by broken glass may introduce a hazardous chemical directly into your bloodstream. Dispose the glass in a designated broken glass container. After you've finished an experiment, wash and dry glassware. Return reagents to the storage area. And clean the workbench surface with ethanol or isopropyl alcohol. If a safety violation occurs or you notice any unsafe condition in the lab, report it immediately to your supervisor. Be on your best behavior. In our next lesson, we'll look at some specific chemical hazards that are common in laboratories.
This section will focus on 3 critical areas: the safe use of chemicals during lab work, proper storage to prevent accidents and contamination, and the correct disposal methods to protect people and the environment.
Ben Franklin once said, "By failing to prepare, you are preparing to fail." It's vital that you prepare for each lab activity. Before you begin, determine the possible risks, wear the right PPE, and be aware of any protective measures and emergency responses that are pertinent for the chemicals that you'll be working with. When diluting acids or bases, always add the acid or the base to the solvent, such as water, not the other way around. Pouring the solvent into an acid or base can cause a violent reaction, and you may get burned. Never remove chemicals from the lab. Use a break-resistant secondary container to transport chemicals between lab spaces. Chemicals must be handled safely in order to avoid skin, eye, or inhalation exposure. First, let's talk about protecting your eyes. As we mentioned in our lesson about PPE, safety glasses with side shields offer some protection, but they won't help you when working with a potential splash hazard. Splash goggles are more effective at protecting your eyes. Chemical splash goggles should be marked with the code Z87.1. This code indicates compliance with American National Standards Institute. Prescription glasses don't offer adequate eye protection. Wear safety glasses, goggles, or a full face shield over your prescription glasses. Corrosive chemicals will harm you if they splash or come into contact with your skin. A lab coat and gloves will help protect your skin to a degree, but a full-length chemical-resistant lab apron is the best choice when working with splash hazards. If you're working with an especially corrosive chemical, use full arm-length rubber gloves instead of the typical nitrile gloves. Some chemicals in the lab can harm you without even touching you. That's why it's important to be aware of inhalation exposure. Never smell chemicals. Always work with toxic chemicals under a fume hood. And keep containers closed tightly if you're not using them. If a large chemical spill occurs, evacuate, seal off the lab, and notify the authorities. Large spills can produce excessive vapors. They have to be cleaned by qualified personnel. Don't re-enter the lab until your supervisor gives you the all clear. Flammable chemicals require special handling techniques. First, always know the flammability and explosive potential for each chemical you're working with. Keep flammables away from all ignition sources, such as Bunsen burners or hot plates. Store flammable chemicals in a dedicated and grounded storage cabinet. When you're finished working in the lab, properly dispose of chemicals and waste according to federal, state, local, and institutional requirements. Use chemical-resistant plastic or metal containers for waste disposal. Solvent should never be evaporated under a fume hood as a means of disposal. Check with your lab supervisor for the best way to evaporate solvents. Any materials used to clean up a chemical spill, such as paper towels, are also considered hazardous waste and must also be disposed of accordingly. Preparation is the key to handling chemicals safely in the lab. Know what you're working with, how to handle it, and what to do in case of accidental exposure. In our next lesson, we'll talk about a few other common lab hazards that you need to prepare for.
Carrying these safety practices into your everyday work helps keep our labs safe for everyone. A key part of that is taking the time to get to know your lab, its equipment, and the safety features that support you. Each lab is equipped with a storage cabinet that uses UV light to sterilize safety glasses between uses. This ensures that every pair you take is clean, sanitized, and ready for safe lab work. Always return your safety glasses to the UV cabinet after use so they can be properly disinfected for the next person. Different methods of chemical containment offer different types of protection. For example, a fume hood protects you from hazardous fumes. A biosafety cabinet protects your samples and you from biological agents. Know which one to use. Biological specimens that are grown in microbiology need to be autoclaved prior to disposal. Media, some solutions, glassware and tools need to be sterilized by the autoclave. This is done by the biology laboratory technician. The autoclave should always have distilled water used in it. Do not open the autoclave while pressurized. Be sure to use autoclave tape to label the items that go into it. Heat-resistant gloves must be used for safety. Anytime the autoclave is being used, it should be documented in a logbook. Store chemicals in the right cabinets. Flammable cabinets for solvents and fuels, corrosives cabinets for acids and bases. Never mix incompatible substances. Oxidizers can be on the shelf so long as they are not next to flammable items. Always inquire with the chemical hygiene officer or the lab technician if you are ever unsure of something being out of place. It is best to always keep safety in mind.